Okay, for part 3, it now says assuming that the model is reliable, so assuming we can actually use this equation here, find the value of the surface area of the pond. So we will find that by thinking about what happens when T gets really big, because as T increases, the pond gets covered more and more and more by these water lilies, so eventually the whole thing's covered. So if we know how much the water lilies takes up, that will be the surface area of the pond. So there's a couple of ways that you can do this. You can think, well, the main way is to think about what happens as T gets bigger, as T tends to infinity. Now if we try and think about that as the equation looks, we're going to struggle. But if we divide the top and the bottom of the fraction by e to the kt, what we want will come out. If we look at this particular part of the fraction, as t increases, 1 over this will get smaller. So because t is on the bottom, as t increases, the bottom increases more and more and more and more and more, and the overall fraction will get smaller and smaller and smaller and smaller, and will tend to 0. So that will then lead us to 250 over 1. So the surface area is 250 centimetres cubed, I think it was. Just check that. Meters cubed. Meters squared, of course it is. The other thing you can do is just type this whole thing into your calculator and pick a fairly big number for t. So if we look at t when it's, say, 100, if you type in 250 e to the 100, you don't need to worry about k because it's just going to be our big number, all over 24 plus e to the 100, it will tell us that it's 250. You could check it at 90 or 80 for the power and see that slowly it will get towards 250, but 100 is big enough to see that it's going to give us the area that we need. So those two methods both work fine to get you your area.